In this section of our notes today, we are going to be talking and discussing force, speed, and direction. A force, by definition, is a push or pull of an object. But what you have to understand is that all forces have both a size and a direction. So if you see a change in the speed or a change in the direction of an object, it has created a force every single time. When we talk about force, we are always using the unit of measurement, which is known as the Newton, or newtons with an S. Its abbreviation will be 1 capital N, and yes, capital is important. So the force of an object does not guarantee that the object will move. So, example, if you're sitting on a chair, you have an existing and exerting force on that chair, but there's also an exerting force on the chair coming from the floor, which is why the chair is still. Obviously, if your chair has wheels, this is not what I'm talking about. I'm talking about a chair such as what you're sitting in the classroom. You also need to understand that that would be considered net force. Gravity is the Earth's force, therefore it's there all the time. So if forces are moving in the same direction, you would just add them up. And this would be a great example of something like moving furniture. The two forces are added to determine the overall net force, such as in the equation below. You have 25 newtons. You add 20 more newtons, which give you a total of 45 newtons, and they're all going in the same direction, as indicated here. So most times, or a lot of times, that's not how reality is. So forces often move in different directions. Example, these two dogs playing in this image. You have a net force, which is the large force minus the small force. In this particular situation, you have the larger dog, who has 20 newtons to the right, pulling in one direction for the game of tug of war. On the left, you have the smaller dog who's pulling 15 newtons to the left. When you take the larger force of 20, subtract the smaller force of 15, you are left with 5 newtons. If you notice, the newtons in the answer are 5 newtons to the right because that is your net force, because you have more newtons on going to the right than you do going to the left. So when we are talking about this, we are talking about a balanced versus an unbalanced force. So if something is going to be balanced, that means the forces of the object produce a net force weight, basically, of 0 newtons. They even and equal each other on both sides. Imagine those two dogs again. If they both had been 15 newtons in opposite directions, they basically would have had a balanced situation force. Probably wouldn't have been a very fun game of tug of war either. So balanced forces do not ever cause the non-moving object to start moving. That's not how this works. So when you have the net force of an object that's not 0 newtons, the force will become unbalanced, such as in the example before with the 15 newtons versus the 20 in the game of tug of war. Unbalanced forces are going to produce a change in motion, thus you're going to have that movement occur. Unbalanced forces are necessary to cause any non-moving object to begin to move in any direction. Example, going back to the chair, the balanced force. Your weight's being pulled down, the chair is being pushed up, both equal 0 newtons in the end. There's no motion because there is 0 net forces created. But an unbalanced force, going back to our game of tug of war, motion is causing by the greater force pulled, so you have 2 people pulling to the left, 1 person pulling to the right. Obviously, they are unbalanced because the 2 to the left are pulling and have a stronger force. Therefore, you have a positive net force being created. This is unbalanced. This is balanced. All right, so to determine the net force, you have to look at the way they're going and the newtons being exerted. So in the first one, you have 5 to the right plus 5 to the right equals 10 to the right. So the object's going to move right with 10 newtons of force. On the second one, you have 5 to the right plus 5 to the left, which equals 0, because now you have to subtract the forces. Now you are creating a balanced force and no movement will occur. The third example, 5 to the right plus 10 to the right is 15 to the right. Now you are going to have that force go moving to the right with 15 newtons. 5 to the right plus 10 to the left. Now you're going to have 5 moving to the left because you have to subtract your forces again, and now 5 newtons move left. 5 to the right plus 15 to the left is going to give you a 10 to the left. Therefore, you're going to subtract again, and your 10 newtons of force are going to move it left. Now, you can also go up and down. Here we have up 10 newtons, down 5 newtons, which gives you a net gain of 5 newtons moving in the upward direction. So here are some more real life examples. This is how the chart is going to be when you are looking at net forces. So we have the forces here. We have 12 newtons moving up to the 1200 newtons moving up to the 800 newtons moving down, which is a net gain or a net force of 400 newtons in the direction of up. We get that because 1200 minus 800, when they cancel, this one goes away and we are left with 400 coming from this top number. In the second example, we have 600 going up, 800 going down. This being the bigger number, we're going to have 200 newtons going down as our answer. And here we have 50 going up, 50 going down, which cancel one another out, but we also have 20 newtons going to the left. So 20 newtons left is going to be our response. All right, so situation A. Pause the video and see if you can solve this one here. As you can see here, we have 3 newtons going up, 3 newtons going down. They will cancel one another. We have 5 newtons going to the left and 5 newtons going to the right. So our response should have been that there is a net force of 0 newtons. All of them are going to cancel out, and you have nothing resulting as a response for situation A. For situation B, take a moment and pause the video to solve. As you note, going up, we have 3 newtons. Going down, we have 3 newtons. Those will both cancel one another out, but we also have 5 newtons going left. Therefore, the net force will be 5 newtons to the left. In situation C, take a moment. As you can see, we have 20 newtons north, or up, 20 newtons down. Because 20 and 20 are the same, they will cancel each other out, leaving us with a 0 newtons net force. Situation D, we have 40 newtons up, 25 newtons down. Take a moment, solve it, and you should get 15 newtons up. Still resulting in an unbalanced situation or net force. All right, friction is a force that opposes motion because 2 surfaces are in contact. We've worked and discussed friction at various points throughout the year. Friction can cause anything that is moving, such as a ball, such as you walking, such as anything, to slow down over time and eventually stop. It's why you would roll a ball, and if it rolls into the grass causes it to come in contact with that ball, and it will eventually slow it to the point it no longer is in motion. The amount of friction between the 2 surfaces is going to depend on so many different factors. 2 factors will include the force pushing the surfaces together, as well as the roughness of how that surface is. So if you want to learn more about friction, log into this Discovery Ed video. Hint, hint, I would highly recommend you do that to study more about this.